How do you find all female, aged 25 to 30, recently active, and high-spending users among 1 billion in milliseconds? The answer is Roaring Bitmap. It compresses massive user sets into tiny bitmap structures that make set operations blindingly fast. A bitmap is a massive array of zeros and ones. Each user ID becomes an index. If user n has this tag, set bit n to 1. For example, users 2, 5, 8, and 11 have the sports lover tag, so their corresponding bits are set to 1. All other bits stay 0. A plain bitmap is simple, but storing 1 billion users takes 125 megabytes. When users are sparse, countless zeros waste space. Roaring Bitmap solves exactly this. The array container is Roaring Bitmap's choice for sparse chunks. When a block of 65536 holds fewer than 4096 user IDs, array container is used. Internally, it is a sorted array of 16-bit integers, the lower 16 bits of each ID within the block. Sorted order enables binary search for single lookups, and two array containers can be intersected with a two-pointer merge in linear time. The space savings are dramatic. Storing 8 IDs, a raw bitmap needs 8 KB 65536 bits, while array container needs only 8 by 2 bytes equals 16 bytes, over 500x smaller. Of course, as a block grows denser and exceeds 4096 elements, Roaring Bitmap automatically converts the array container to a bitmap container, always maintaining the optimal storage strategy. When a block reaches 4096 or more user IDs, Roaring Bitmap automatically upgrades the array container to a bitmap container. A classic, fixed-size 65536-BIT bitmap. Inside the bitmap container, every bit maps to a user ID. We show 8 bits here. In reality, there are 65536. Bitmap A represents VIP users. Bitmap B represents ages 25 to 30, both very dense. And speed is the bitmap container's biggest advantage. The CPU applies and byte by byte processing 8 bits per instruction. Intersecting two 8 KB bitmaps takes just tens of microseconds. Bitmap container is always 8 KB, regardless of density, which means it maximally exploits CPU SIMD. AVX 512 processes 512 bits at once, enabling intersection of 200 million user bitmaps in under a millisecond. The run container is the third container type, designed specifically for consecutive ID scenarios. Imagine a batch of new user registrations getting sequential IDs. Array or bitmap containers would both be wasteful here. Take 3 batches of consecutively registered users. The first from ID 100 to 1099, 1000 IDs. The second from 5000 to 5799, 800 IDs. And the third from 20000 to 20499, 500 IDs. Run container uses run length encoding. Each consecutive range becomes a pair of numbers, start and length. 1000 consecutive IDs become just 100, 1000, 4 bytes, a compression ratio of over 500s. 3 batches total 2300 consecutive IDs. Array container would need 4600 bytes. Run container needs just 3 pairs, 12 bytes. A 383's compression ratio. Roaring Bitmap automatically decides when to use run container, with no manual intervention needed. In a user tagging system, every tag maps to its own Roaring Bitmap. Billions of users and thousands of tags are just thousands of bitmap objects in memory. Every time a user action occurs, registration, purchase, browsing, the system writes that user ID into the corresponding tag bitmap. Writing means flipping exactly 1 bit from 0 to 1. The storage efficiency is remarkable. 500 million female user records take only about 8 megabytes in Roaring Bitmap, dozens of times smaller than storing ID lists. Now we want users who are female and aged 25 to 30. This is exactly where Roaring Bitmap shines. Intersecting two bitmaps is just an AND operation. Bit by bit, computed byte by byte in parallel, extremely fast. Intersecting two bitmaps with hundreds of millions of users each takes just milliseconds on a modern CPU. Similarly, OR gives the union, satisfying any condition. Not flips all bits. Any complex tag combination query can be decomposed into these basic operations. Here is a complete precision marking case. Target users who are female and in Shanghai or Beijing or Guangzhou and active in the last 30 days and high spending. The city condition is an OR relationship. Being in any one city suffices. First, or the 3 city bitmaps together into one Tier 1 city users bitmap. Then, and the 4 bitmaps, female and Tier 1 city and active and high spender. 4-way and on raw bits, no user records are ever read. The result arrives in milliseconds. With this user ID list, you can push targeted campaigns. No SQL queries. No table scans, just bitmap operations. The elegance of Roaring Bitmap lies in its self-adapting nature. Array for sparse, bitmap for dense, run for consecutive, switching automatically as needed. This makes it memory efficient and blazing fast at billion user scale, and OR and NOT are all bitwise operations. And modern CPUs with SIMD instructions process 256 bits at a time. Elasticsearch, Druid, ClickHouse, and Spark all use Roaring Bitmap internally to accelerate aggregation queries. The next time you get a precision recommendation on an e-commerce platform, Roaring Bitmap is very likely behind it.